This is Jack Jackson. We're going to be looking at the practice test 4 today for trigonometry, and we are going to go through and work it. Complete the following statement. If you know two angles of a triangle, you can determine the third angle because the sum of all three angles is 180 degrees, or of course pi radians. That's the angle sum theorem. When solving for the angle of a triangle, we use the law of sines in the form sine A over A equals sine B over B equals sine C over C. So that's part C here. Of course, we can have this thing, all of them upside down. A over sine A equals B over sine B equals C over sine C as well. Okay, we're going to solve a triangle. The given information here is an angle side angle case. First thing, of course, we can do is to find the other angle. So you take 180 degrees, and we want to subtract 36, and then also subtract 57, and we're left with 87 degrees. So that's angle A. Now we know a side and an angle opposite, but we don't know the other side. So that's a law of sines case. So we're looking for side B, for example. And so we know that B over sine of angle B is, let's go back and see which one we have. We have the ones that match. We have A and A that match, that are opposite each other. So then we use that, A over sine of A. So we know the entire fraction on the right. We know the angle B now, so we can solve for side B as A over sine of A, and then we're going to multiply by sine of B in the numerator. So now just plug in the numbers on the right hand side. A is 11, B is angle B is 57 degrees, and angle A is the one we just figured out, 87 degrees. Alright, we just got to do that on the calculator here. Okay, here we go. Okay, first of all, let me check my mode. Right now I'm all in radian mode, so I'm going to have to enter the degree symbol or change it to degrees. So I'm going to do 11 sine of 57 and put the degree symbol on there, divided by the sine of 87 and put a degree symbol, and enter. And that's this other side, 9.238, etc. And so that's going to be what we put in here, 9.24 when we round to hundreds. Hundreds is two places, tenths, hundreds. Okay, and similarly we can find side C in a very similar manner. C over sine of angle C is, again, A over sine of angle A. So C is A sine of angle C over sine of angle A. And again, this is sine of, I believe this was 87 degrees. Let me look it up to be sure. 87, and A was 11, and angle C is 36 degrees. So if we look at our previous entry, the only thing we need to change is the 57 has got to be a 36. So I can go second enter to get that previous thing up, and go in here and put in 36. And you get 6.47 if you round to hundreds, which is what they have here. Okay, so two observers are on opposite sides of a flagpole. The angle of elevation from the observer to the top of the pole are 16 and 17 degrees each. Find the height of the flagpole. So if they're on opposite sides of the flagpole, okay, let's see here if I can get this to... So we got a pole here, and we got the ground here, and I assume the pole's standing straight up, so that would be a right angle. And one of the guys is out here, probably further out than this, but this angle right here is 17 degrees. I've got it a little bit bigger than that, but this guy's a little closer. His angle is, the 17's a little closer. This one's further away. He's 16 degrees. And we know the distance apart of these two people is 500 feet. So we can do a little law of sines or law of cosines to find to solve for say one of these sides here, and then we use this right triangle trigonometry to solve for the height here. So we'll call that A, H. Maybe we'll call this A and B. The big angle up here is C. So that makes this little b, little a, and c. And notice, let's see, we can find the big angle at C. Big angle at C is 180 degrees minus 17 degrees minus 16 degrees. Well, I got a calculator, might as well use it. 180 minus 17 minus 16 is 147 degrees. So that's the bigger angle here at C. Okay, and now we know angle C and side C, so we can solve, say for side A there. A over sine of A is C over sine of C, and so we multiply both sides by sine of A, and we get this expression. And so this will allow us to solve for A. 500 feet times the sine of 17 degrees over the sine of C, which is 147 degrees. Okay? So 500 times the sine of 17. You know what? Let's just go to degree mode for a little while. So I'm in degree mode now, so I don't have to type the degree symbol, and divide by sine of 147 degrees, and this should give me A. Okay, so you may get back to that in a minute. Now we know that A over H, H over A, is the sine of the 16 degrees. So H is A times sine of 16 degrees. So if I just take that previous answer times the sine of 16 degrees, that will give me my height of the flagpole. So almost 74 feet high, 74.0 feet in fact, to the nearest tenth. Okay, next question. Okay. Solve the triangle if possible. Okay, so let's draw out what we have here. We have okay, let me draw the angle B. 43. That's not too far off of 43 degrees. So there's 43 degrees. One of the sides next to it, let's say this one, is 39 units, and this one here is 34. Now it might be here or here, possibly, maybe, for the other side. So this is B, and this is C, and this is angle B, so that makes this angle C here, or the angle C here. And then this makes this side either here or here, could be side A, and then the angle up here, either this one or this one, is angle A. So we could have sort of two things like this, or it might just be one. We don't know yet. We can use the law of sines to find this. Notice this is the SSA case, so that there might be two possibilities. So let's see. The first thing, I've got B and side B and angle B, and I've got side C. So let's see if we can find angle C. So we know sine of angle C over side C is the sine of angle B over side B. So we know sine of angle C is C times the sine of angle B over B. We know everything on the right side. Now the problem is when we go from here, this is where you have to look at the two possibilities. Okay, one possibility is that C is the arc sine, inverse sine of this. Or C could be, well, they're using degrees, so I'll use degrees. 180 degrees minus, let me call this C1. It's 180 degrees minus what I got for C1. So there's two possibilities. Maybe. We'll see. Okay, so let's see what happens here. So let's work this out. Side C is 39. Angle B is 43 degrees. And side B is 34. Alright, let's see if this even is a possibility at all. Okay, now I'm in degree mode, so my answer will come out in degrees, which is what I want here. Let's double check, yes. Okay, so we do inverse sine of parentheses 39 times the sine of 43 degrees. Close the numerator, divide by 34, close the inverse sine. And this is one possibility for C. So 51.470932. Let me store that as C. That's one of the possibilities for C. Okay, the other one is 180 degrees minus that previous answer. So the other possibility is C2 is 128.5290678 degrees. Now, the thing you have to check at this point is if this one and angle B already add up to more than 180 degrees, you can throw this one out. So if we add 43 degrees to that, we still see that we have room for an 8.5 degree angle still for the other angle. So it is possible. So it looks like we're going to get two solutions here. Okay, so we have to look at each one of these. So I've got this guy stored as C right now. Okay, now I can find the I can find angle A then. I'll call it A1. Now let's look at the picture. In the picture, this is the C1 is the acute angle here. A1 then would be the bigger one here. Okay, so alright, so what is A1? It's 180 degrees minus the B, which is 43, minus what we just got for C. And so that leaves 85.5290678 degrees for A. We can find side A by law of sines or law of cosines, but A over sine of A is, let me go back to the one I knew to begin with, B over sine of B. So A is B sine of A over sine of B. Okay, so what is side B? Side B was 34. angle B was 43 degrees, and angle A was this guy. Alright, so let's do that on the calculator. 34 sine of my previous answer divided by the sine of 43 degrees. So A is about 49.70178863. Okay, so that's one option. Let's go ahead and put that one in. So here A is, let's see, how far do we go here? 1 decimal place. 49.7 for the length of side A. And the angle A is 85.5 degrees. And angle C was 51.5 degrees. So that's one possibility. Now we have another possibility over here. Okay, so this time angle A, A2, we actually figured that out a while ago. Well, no, we were close to figuring that out. It's 180 degrees. Okay, so 180 degrees minus C, that's 128. Okay, so if you do 180, of course if you do 180 minus that, we'll be back at 180 minus our answer. We'll be back at the 51 point something, what we had before for C. And we take away from that the 43, I believe it was, for angle B. And that leaves about 8.5, about 8.4709322 degrees. So about 8.5 degrees. Okay, and that's the angle A that we see here for our second possibility. Now, to get side A, if you look, I'm using exactly the same steps, right? A is still B sine of A over sine of B. B is still 43 degrees. Side B is still 34. The difference is this time I'm putting that value in for A. So 34 sine of our previous answer divided by sine of 43. So about 7.3438. About 7.3 for side A, which as you'll see is what we have here, 7.3 for side A. And then to, is that everything? Yeah. There's the 128.5 for C. There's the 8.5 for A, and angle A, and then there's the 7.3 for that length. Alright, so there's the side angle case. Be sure that you check out the two possibilities when you're solving for the angle. Next question. Okay, a point on an island is located 18 miles southwest of a dock. Okay, so we got a dock. So the ship leaves the dock at 1 p.m. traveling 12 miles per hour, and he's going west. So this is north, south, east, west. The origin is the dock. Okay, and so our first guy here, we'll make it blue, is going here to the west, Okay. And he's going 12 miles per hour times t hours will be that length. Now, the point is 18 miles southwest. Now, they didn't give us an angle. So they could have said south so many degrees west, but if they don't give you an angle, it's exactly 45 degrees then for this angle. Okay? And he's going out a total of, that's 18 miles. And there's our point. Okay? At what point is he 14 miles from that point? So this is 14 miles. At what time is that 14 miles? So we have a okay, so we have 45 degrees here. And so we have a, let's call this guy C, and we have a side and an angle opposite. So let's call that A. So we know that, let's see here, 45 degrees. We have, okay, this is a side-side angle case, so there might be more than one answer here. Let's work this out. So we have we need to find this angle here first, angle C. So we know sine of angle C over side C is sine of angle A over side A. So we know sine of angle C is C sine of angle A over side A. Now, this is the one that possibly might have two cases. So one case is C, we'll call it C1, is the inverse sine, arc sine, C sine A over A, or C2, which is 180 degrees minus C1. So let's find C1. C1 is inverse sine of C is wait a minute. I don't know C. What am I trying to do here? Oh, I can't do this one. I need to find angle B. Angle B first, because we know side B. So change the C's to B's. There we go. So B1 is one we got to find first. So change that to a B. Okay, because we got to know everything here. We do know B. B is 18 miles. Angle A we do know is 45 degrees. And side A we know is supposed to be 14 miles. Or B2 is 180 degrees minus B1. Okay, so let's find B1 equals, okay. Again, I'm in degree mode, so this will give me degrees for my answer. 18 times the sine of 45 divided by 14. This is going to, in fact, I'm going to store this as B. So about 65.3864023 degrees. About 65.4 degrees. I'm not sure how, well, we're going to come up with a time in a minute. But we won't round off here. We'll use we'll use the value that we have saved there. Okay, or what's the other possibility? 180 degrees minus that answer we just got. The other possibility is B2 is 114.613597. So notice that you take the bigger one there, and if we add the angle we already have, which is 45 degrees, if this goes over 180, we can eliminate that. Okay, it's shy of 180, so there are going to be two possibilities. Okay, two possibilities. So let's work with this one right here. So with this one right here, we now know the angle. So there's basically a position, somewhere over here and somewhere over here. Two different places where it's the same distance from this point. Okay, so we're going to use the acute one, which is actually the further away one. Now let's find side C. Okay, so C, well, we need to use law of cosines, we need to find angle C first. So let's find the angle C, C1, which is the angle. So that's 180 degrees minus the 45 degrees for the angle A, minus the angle B that we stored, which is this 65 something, and that leaves 69.61359765 degrees. Okay, let me store that as angle C. Okay, now to get side C, C over sine C, side C over sine of angle C is, let's go with the one we originally had, which was B, B over sine of B. So C is B sine of angle C over sine of angle B. I've got these saved as B and C, and the little b was, picture, 18. 18 sine, and this guy is the C, which is about 65 degrees. Don't put in 65 though, put in what we have. And the B was about, the B was about 65 degrees, and the C was about 70 degrees. Okay, but we're going to put it in this way. 18 sine, and then I've got this saved as alpha C. And then I'm going to divide by sine of the other one, which I have saved as alpha B. And this is going to be my distance. So side C could be 18.55887396 miles. Okay? But now, that's how far he went. How long is it going to take him to get there? Well, if we take that, 18.55887396, okay, so we have 18.5588 whatever miles is how far they went. Now, let's look back at our problem here, and we'll notice that it is going 12 miles per hour. So we have 12 miles for every 1 hour. If we write it like this, the miles will cancel. So we just need to divide this number by 12 to get the hours. 1.5465723 hours. And he started at 1 p.m. So it's almost 3 o'clock. So 2 something p.m. So we need to take the 0.54 or whatever. So subtract off the 1. Take the 0.54 and then multiply that by 60 minutes per 1 hour. So this turns out to be 1 plus 0.54, 1 hour plus that many hours times 60 minutes per 1 hour. So multiply that by 60 and we'll get the minutes, about 33 minutes, so 2:33 p.m. So there's one option. Okay. Now, that was only one of the possibilities. The other possibility is we have this for B, right? So let me take that. So we take 180 minus our old B. That's that one. Let's store that as alpha. That's our new B. Okay, now to get C, is it C? Yeah. To get C2, angle C, we do 180 degrees minus A minus B2. So 180 minus A was what was A? 30. Oh, A was 45 degrees in this one, right? Yep, A is 45. Okay, so 45 minus what we just stored as B, and we get 20 point something degrees for C. Let me store that as my new value for C. Now from there it works the same, the formulas are the same. C is B sine of angle C over sine of angle B, but now I'm using the B is still 18, but now I'm using the new version of C, this one here for C, and I'm using this version for B. So there's my C and my B, which I have stored. So I can go 18 sine of C, that's the new version of C, the 20 point something degrees, divided by sine of the new version, the 14 point something degrees for angle B, which is alpha B. And this is going to give me my new value for C, 6.89697067, and that's miles. And just like the last time, we're going to do the same thing. We're going to take that 6.89697067 miles, and we're going to multiply by 1 hour for every 12 miles, like that. So in other words, we're going to divide by 12. So we're going to take that and divide by 12. 0.57 something hours. And we're going to multiply that by 60 minutes per hour. So in other words, take that answer, multiply by 60, we'll convert it to minutes. So about 34 minutes, and we started at 1 o'clock, so this would be 1:34 p.m. So there are two possibilities. So as this boat or whatever it was going along this way, that reaches a point where it's 14 miles away, and that happens at the first time at 1:34 p.m. and then it keeps going, and then eventually it reaches another place where it's again 14 miles away, and that happens at 2:33 p.m. And you'll see that's exactly what they have there. Okay, so we've done 6 questions out of how many? Out of 30. Let's stop out of 40 or so. Let's stop here, and then we'll pick up the next part in the next video.